question of how self-initiated movements are orchestrated has intrigued generations of philosophers, clinicians, and scientists. It is very difficult to study this question in animal models, given the complexities of assessing volition. In this study, we had a unique opportunity to evaluate how and when neuronal circuits in the human frontal cortex change their activity patterns before self-initiated movements.
The question in my mind dates 20 years ago, and at the time I can remember that when applying stimulation to the brain in an attempt to define the motor areas, the patient suddenly said, I have an urge to move my hand. This was indeed totally unexpected. I mean, we expected to get an actual movement, and here we got an urge. It so happened that this area was the supplementary motor area. It was only years later that we could really address this question on the single neuron level. This study essentially dates back to the pioneering work of Benjamin Libet. Libet's ingenuity was really posing the question, what is the temporal chain of events with respect to the rising of volition? And he was attempting essentially to ask his subject to tell him the exact time where this volition to move really arises. So it was really his ability to assign a clock to that process, which was indeed this decisive change and a decisive insight. So in the present study, 12 patients with intractable epilepsy who were implanted with intracranial depth electrode participated. They were each faced with a clock. The clock made very fast revolution. Each revolution was 2.56 seconds. The subjects were instructed to press a key whenever they felt an urge to do so, and at the same time look at the clock and report the time where they first felt the urge to move.
We found that individual neurons gradually changed their firing patterns several hundred milliseconds before subjects even became aware of their own decisions. In some striking examples, pre-volitional activity occurred several thousand milliseconds in advance.
This interval of time really enabled Libet to come up with what he called the veto hypothesis, essentially saying, yes, well, things are really predetermined before our conscious feeling of will, yet we have those 200 milliseconds to really apply a veto and saying, no, I really do not want to do that, and then stop the actual act. So essentially, the results were two. One, there was a gradual increase or decrease in the firing rate as W point was approached. This firing rate was in neurons in the medial frontal lobe and not in other areas such as the medial temporal lobe, from which we also recorded. In addition, as W was approached, there was recruitment of more neurons exhibiting this type of phenomena.
We went on to use machine learning techniques to show that we can decode volitional onset with high accuracy and in single trials from the activity of small ensembles of neurons in the human supplementary motor area and anterior cingulate cortex.
I think it is fair to say that in the medial frontal lobe, the neuronal signals are quite robust. In fact, they are so robust that several hundred milliseconds prior to the rise of volition, we can actually predict that event by using the activity of a few neurons, say several dozens of neurons, and this can be done on a trial-by-trial basis, that is on a single trial level.
We're very excited about these results because we can begin to think about the fundamental problem of volitional control in a rigorous and systematic manner.
I think it is fair to say that Libet's original experiment was a subject of considerable controversy over the several decades since the original experiment. Of course, it has raised in the mind of some people in a very acute way the mind-body problem in a rather dramatic fashion. Some people had considerable difficulty with the paradigm, and especially with possible implication to the question of free will. I'm sure this still stands in the history of neuroscience as a very unique experiment and a very unique challenge. I mean, if we are really cognizant of our will to move, and our brain starts acting before that, then who is really in control? Really, where does the actual volitional signal start? But even more exciting is the possibility to predict action before the will to perform action actually arises. That I think opens an interesting array of possibilities in the future.